Okay, so when we are looking to express the area of a parallelogram in terms of this, all it's really doing is asking us to apply a formula that we know. So the area of a parallelogram is equal to the base times the height. And because we're looking at this in a three-dimensional figure, we want to take the magnitude as well. So make sure that it's not in terms of i's and j's. Okay, so that'll stop it from being vectors. So in this case, we're looking for, now it's A, B, G, H, A, B, G, H. So we're looking at this face here. So A to H is expressed as Q. So that'll be Q times A to B will be R. So Q times R, that's how we would get the area of that parallelogram. So that expression there would just be worth 1 mark. Okay, so assuming A is the origin, express the vector position of the line passing through B and D in terms of P, Q, and or R. So as you can see, I've got this little thing over here. I've just dragged it across so that you can still see the picture while we're working on this. So all we need to do to work this out, now we know that a vector equation is generally expressed as R is equal to A plus K and then the direction. So first thing we're going to do is we are going to, passing through the points of B to D. So we're looking for this line here, B to D. Okay, so first thing I need to do is I can work out the point of B here because it's just A to B. So A to B is expressed to R, so that first part there is going to be R plus. K is some constant, now we have to work out D. So we're working out the direction. This one going up like that is R, this one going that way is going to be P. To work out the vector that joins B to D, we need to reverse the direction of R. So it's going to be P minus R. Now that as well, I think, is only worth, I think it's 1 or 2 marks. So you get 1 mark for recognising that, maybe 1 mark for recognising that. The two internal diagonals are parallel piped A to F and B to E are contained by the parallelogram A, B, F, E. Yep, okay, so we're looking now at the internal diagonals. So express both A to F and B to E in terms of P, Q, and R. So let's look at A to F first. Now, if we think about drawing a little map of how we would get there, go away. I would have to go, or one way I could go is from here to here, and then from here to here, and then from here to here. So our vector that's going to join A to F is going to be equal to P, so this A to D, and then D to E is going to be the same as A to H, which is Q, so plus Q plus, and E to F, same direction as A to B, so that's R. Okay, so that one, pretty easy. Now let's look at the one that joins B and E. So B to E. Now if we're just looking at the vector of it, we don't need to adjust for its height here. We just start in that position. So to figure that one out, I'm going to go from here to here, from here to here, and then we're going to go down this part here. So that's going to be P from here to here plus D to E is the same as A to H, so that's just going to be Q. And now instead of going up, we're going reversing the direction down, so minus R in this case. So 2 marks, you'll get 1 for this, 1 for that. Okay, use your results from 11C to prove that the internal diagonals A to F and B to E bisect each other. So for this to be a proof, we need to make an initial statement. So required to prove position of midpoint, same for A to F and B to E, something like that. Just tell us what you're going to do before you do it. Okay, so to get the midpoint of A to F, midpoint of A to F, I'm just going to halve the vector that makes A to F. So P plus Q plus R, pretty simple. To get the midpoint of the vector that's joined by B to E, now remember this is only like the direction of it. I have to account for how far up it was shifted. If you look back at my diagram, you'll see that there was an R, so it was shifted up by length R plus half of that vector, P plus Q minus R. Now, if I think about expanding this out, I'll end up with half of, or minus half of R plus 1R will give me, positive a half. So then I can say that this is going to be the same as this. So from that point, I can say, therefore, left-hand side equals right-hand side, position of midpoint is same, therefore AF and BE bisect each other. Now, a couple of things I want to highlight. This word prove here means that you're going to get a mark for making an initial statement and an end statement. Otherwise, your two other marks would come from determining the midpoint of your two lines. But if you don't state it out as a proof here, then you'll miss 2 of the 4 marks.